Hi guys, welcome back to another video. In today's video, we're talking about the 2025 AIME 1 problem number 4. Please pause the video right now if you'd like to try this question yourself, and click back when you're ready to see the solution. Okay, let's get started. We're going to begin by factoring out this expression right here into 4x minus 3y times 3x plus 2y. Now, obviously in the contest, you might not get this at the first try, but you can obviously experiment by splitting up the 12x squared and the 6y squared into separate factors and then multiplying to see which ones come out to negative xy. Okay, let's keep going. We're going to set this equal to 0. Now, if you multiply two things and you want them to equal 0, at least one has to be equal to 0. So at least one of these two have to equal 0. We're going to split this off into cases where case 1 is going to be where this equals 0. Case 2 is going to be where this equals 0. And lastly, we're going to check for any cases that overlap with one another and subtract case 1.5, I'll call it. So we're going to add case 1 and case 2 together, and we're going to subtract case 1.5. So that's basically what we're going to be doing. Okay, so let's jump right into case 1. 4x minus 3y equals 0. That means that 4x equals 3y. X equals 3 over 4y. And that means that y has to be, if y is 100, x equals 75. So y can be any multiple of 4 between negative 100 and 100, and x will be an integer. And y equals negative 100, x equals negative 75. So for every integer, multiple of 4 integer between negative 100 and 100, there will be a solution, a different solution. So we just have to find the number of numbers in this sequence. So let's divide this whole sequence by 4. Then it becomes negative 25, negative 24, all the way to 24, 25. If we add 26 to the whole sequence, it's 1, 2, all the way down to 50, 51. So there are 51 cases that satisfy case 1, 51 sets of x and y. Alright, let's get to case 2. I'll just circle this. Three x plus 2y equals 0. 3x equals negative 2y. X has to equal negative 2 over 3y. So how can we figure this out? Well, we can do the similar thing, but we know that y would have to be a multiple of 3 so that x is an integer. So if y equals 99, x would equal negative 66. But if y equals negative 99, x would equal 66. So for every multiple of 3 between negative 99 all the way to 99, there is a solution. So if we divide this by 3, we're going to have negative 33, negative 32, all the way to 32, 33. Let's add 34 to this. We get 1, 2, all the way down to 66, 67. So we have 67 ordered pairs that work. That's the solution for case 2. Lastly, let's evaluate case 1.5. We basically want to find where the intersection points of these two equations. And that will happen only at 1 point, 0, 0. Because if you imagine it on a graph, let's rewrite this expression into a y equals mx plus b form, which is y equals negative 3 over 2x. So that's equation 1. And let's do the same thing for this one. Y equals 4 over 3x. This is equation 2. Y equals 4 over 3x. Now imagine for a second that you graph this expression. Let's graph y equals negative 3 over 2x. So it would go through 0, 0, and at negative 2 it would be 3. At negative 4 it would be 6. At 2 it would be negative 3. And at 4 it would be negative 6. So it's like a line right here. For 4 over 3x, we would have 0, 0, 3, 4, 6, 8, negative 3, 4, negative 6, negative 8. So this is the line right here. They only intersect at 0, 0. So that's why that's the one case that's overcounted, this case. Okay, so we'll just come back to our original. We just have to evaluate case 1 plus case 2 minus case 1.5. So we have 51 plus 67 minus 1, which is 117. So our final answer is 117. Thank you so much for watching this video. If you enjoyed this video, please make sure to like, subscribe, and hit that notification bell so you're notified when I make another video. Also, if you'd like to see me explain a certain concept or question, leave a comment down below and I'll get back to you as soon as I can. Also, if you're interested in summer math tutoring for school math subjects, you can check out my website at stemcoachingonline.com or email us at stemcoachingonline@gmail.com. Thank you so much for watching this video, and I'll see you in the next one.